look at maximum and minimum values for functions. It's important to note that for something to be a maximum or minimum value for a function, the input needs to be an element of the domain. Let's start with absolute maximums and minimums. These are interesting because they can occur at endpoints. You just want to be careful because they can occur at closed endpoints, not at open endpoints. Local maximums and minimums, on the other hand, cannot occur at endpoints. Instead, we need to be able to look on both sides of C in order to make sure that f of C is greater than f of x for where x is near C. So these three are examples of local maximums. And these three are examples of local minimums. In order to identify absolute and local maximums and minimums, we like to first identify critical numbers. Critical numbers are the x values where f prime of x, so that's the derivative, is equal to 0 or undefined. Critical numbers are also the inputs at endpoints. And where discontinuities occur. So let's start by identifying the critical numbers. So over here and here, at x equals 0 and 4, we have endpoints. And here, here, and here, f prime of x, or the slope of the tangent line, is equal to 0. So our critical numbers occur at x is equal to 0, 1, 2, 3, and 4. Now that we've identified the critical numbers, we want to figure out where our absolute maximums and minimums occur. The absolute maximum is the highest output that the function can have. So our absolute maximum is 3, and that occurs when x is equal to 1. So the absolute maximum is f of 1 is equal to 3. Next, we'll identify the absolute minimum. This is the lowest value that our function can attain. This occurs at x is equal to 1. So it's f of 4 is equal to about 1.1. Now that we've identified the absolute maximums and minimums, we're going to identify any local extrema. Let's start with the local maximums. This function has two local maximums, one here and one here. The first one occurs at x is equal to 1. The other occurs at x is equal to 3. So this point, at x is equal to 1, is both an absolute and local maximum. Finally, this function has one local minimum at x is equal to 2. When x is equal to 0 and x is equal to 4, we're at endpoints, So these cannot be local maximums or minimums. Let's look at another function. This one's a little more complicated. Let's start by identifying the critical numbers. Our critical points occur at the endpoints, so at x is equal to 0 is one of them. They also occur at discontinuities, so something is going on when x is equal to 1. Then we have another one at x is equal to 2, because the slope of the tangent is 0. Another at x is equal to 4, because the slope of the tangent is equal to 0. Another when x is equal to 5, because we have a cusp. So f of x would not be differentiable, or f prime of x is undefined. Another one at x is equal to 6, because we have a discontinuity. And finally, one at x is equal to 7, because that is an endpoint. The absolute maximum of our function occurs at x is equal to 4. So it is f of 4 is equal to 5. This function is interesting because it actually does not have an absolute minimum. Since we have that open circle there, we can't really be sure exactly what number we're approaching. So the absolute minimum does not exist. Open circles are interesting that way. Now let's take a look at our local maximums. We have a local maximum at x is equal to 4. And another one at x is equal to 6. Then let's identify our local minimums. We have a local minimum at x is equal to 1, at x is equal to 2, and at x is equal to 5.